Now, most permutations can be done using our calculator, and I'll show you how to do that in another topic, but some permutations can be done by hand. We've seen that according to the factorial rule, that n different items can be arranged in n factorial different ways. Sometimes, however, we only need to select some of the items instead of all of them. And so to do that, we can use our fundamental counting principle. So suppose a business owner has a choice of 5 locations in which to establish her business. She decides to rank each location according to certain criteria, such as price of the store and parking facilities. How many different ways can she rank the top 3 of the 5 possible locations? So each ranking being an event, we want the top 3, so that's 3 events. But we would have 5 stores to choose from the first time. Now the store that gets the first spot can't get the second spot as well, so then we would only have 4 stores to choose from, and then we would have 3 stores to choose from. And again, we're using our fundamental counting rule here. So 5 times 4 times 3 is 60. That is a permutation because the order in which we chose them did matter, but we didn't have to use the permutation rule that we'll talk about in a moment. We could still use our fundamental counting principle. Now, for the previous example, the answer was easily obtained, but large sample spaces can make this process very unwieldy. It would be nice if we could use the factorial function, but the factorial function always takes the multiplication down to a final factor of 1. So here we need to stop at 3, which we did. But there is a way to use the factorial function that is illustrated here that is known as the permutation rule. So you would still write the top like you would have the basic factorial as 5 factorial, like you were choosing all 5. But we had to stop at 3, so on the bottom we would write 5 minus 3 and factorial again. So what it ends up doing is simplifying it down to what we actually did. 5 times 4 times 3 is 60. So we can generalize this result by noting that if we have n different items available and we want to select r of them, the number of different arrangements possible is given by n factorial over n minus r factorial. This is commonly called the permutation rule. The permutation rule, when all items are different, is given on the next slide. So let's go there. So, number of permutations, we write it as NPR, where the n is small and the r is small. The n is the total number of items that you have to choose from. Okay? N is the total number of items you have to choose from. Total number of things you have in your group or set. And then R is the number of things you're choosing. So conditions that are required for the permutations rule is that you have n different items available. And we'll have a different rule if items are identical. Okay, so we have n different items to use this rule. We select R of the n items without replacement, and we consider rearrangements of the same items to be different sequences. For an example of number 3, the permutation of ABC is considered to be different from CBA. Even though they contain the same letters or elements, the important thing is that the order matters. So when you read one of these questions, you need to ask yourself, does order matter? If the answer is yes, then you would work that problem as a permutation.